Okay, you know how this is, right? 1 factorial equal to 1, 2 factorial equal to 2, 3 factorial equal to 6, 4 factorial equal to 24, 5 factorial equal to 120, 6 factorial equal to 720. Yeah. Okay, simple as that. But what is 0 factorial? Well, they say that 0 factorial is equal to 1, and that's correct. Okay, now how do we prove this? We will prove it like this. Just divide this by 6, you get 120. I mean, of course, 6 factorial divided by 6 will be 5 factorial, 120. Divide this by 5, you get 24. Simple. 4 factorial is what comes, right? Then divide this by 4, you get 6, which is 3 factorial. Divide this by 3. When you divide 3 factorial by 3, you get 2 factorial, and then 2. Then divide this by 2, you get 1, and then divide this by 1, you get 0 factorial. So does this mean that 0 factorial equal to 1 factorial? Well, yes, 1 equal to 1. But what if it isn't? Or is it? Well, if we put this into consideration, I just want to clarify something. Why is it 0 factorial? What if it's not the case? Normally this cannot be used as a mathematical proof. Proof cannot be like this. To make a certain proof, you have to get a foundation built upon it. This is regular division. One has to actually prove. The factorial actually starts from a natural number series, first of all. Okay, you take n factorial, you will get as n into n minus 1 into dot 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 into 1. 0 does not come in this case. Now, how does a mathematical proof actually works? Suppose we have 13 and 12. Okay, simple. Now, if I just simply do 13 plus 12, what would I get? 25. What if I do 13 square, 12 square? 169, 144. What if you subtract them? 25. Wow, quite nice now. What if you do 13, let us say minus 12? You get 1, right? Now what is the connection in this? Well, if I multiply 13 into 12, 13 plus 12 multiplied by 13 minus 12 equal to 13 square minus 12 square equal to 25. Now it gets really much simpler. A plus b, a minus b equal to a square minus b square. Yeah, this is what it is basically. This is the distributive method of the basic equation. Now the thing is, you can use any kind of example, as long as you can use any three numbers x, y, z, and you could do, if z is greater than x, and y is greater than x, then what you could do is z minus y. Okay, and keep in mind they all need to be part of trigonometry. That thing, RHS rule. That is, if x square plus y square is there, then it should be equal to z square according to RHS. Yeah. So if that's the case, then how could this be possible? Yeah, okay, let's check. Z square minus y square equal to x square. So z plus x, z minus z plus y z minus y equal to z square minus y square equal to x square. Right. And what is this? X square plus y square equal to z square. X is the smaller one, smallest side. Y square is the bigger side, and z square is the hypotenuse. Okay, hypotenuse, z square. Simple as that. Now I have actually proved this theory, this proof of why is this true with reference to RHS and all that stuff. I used RHS. You can use any example of the trigonometry. You can use 3, 4, 5. Let's check. So first of all, 5 plus 4 into 5 minus 4. You have to do it like this. Z should be greater, which is 5 in this case, equal to 3 square. Is it true? 5, 4, 9. 1. Yeah, 9 it is. See? It's like that. Now the thing is, this thing caught me off guard. This cannot be a proof because the first reasoning is, how do you have 0 factorial? Factorial system starts with n, ends with 1. Simple as that. But 0 factorial. How did we get this 0 factorial? Keep in mind that we divided, look, 6 factorial divided by 6, we get 5 factorial. 4 factorial divided by 4, we get 3 factorial. Simple, right? 6 factorial divided by 6, 5 factorial. 5 factorial divided by 5 equal to 4 factorial. 4 factorial divided by 4 equal to 3 factorial. 3 factorial divided by 3 equal to 2 factorial. 2 factorial divided by 2 equal to 1 factorial. Now 1 factorial divided by 1 equal to 0 factorial. Is it the case? Maybe. But what if, which is also equal to 1, right? And it would still be equal to 1 factorial. So what's going on, Kalia? Well, what if this is not true? You see, in multiplication, there is a simple rule that applies to multiplication and division, okay, in both of this case. And there is a similar one in addition and subtraction. What is it? The identity rule. Identity rule. It says that any number multiplied by 1 or divide by 1 will be equal to same. And in here it's the same thing. And any number added by 0 or subtracted by 0 will be same number, right? Now what you do here is 1 factorial divided by 1 equal to 1, which is 0 factorial. How is this the case? When you take, if you take 5 divided by 1, you get 5. Okay. Now look at these factorials. 6 factorial, take it for example, 720. You divide 6 factorial by 1. What do you get? You will get 6 factorial only. It is an identity way. Okay. Identity number 1 is for multiplication and division. So how could we say that 1 factorial divided by 1 is equal to 0 factorial when all we get is the same number by the law of identity of multiplication and division. I genuinely had this doubt. I was just, uh, taking a shower and got this thing in my mind. Shower thought it is. How is it though? You take any number, any factorial. Factorial is also a number at the end. These are all numbers. Just a series of numbers multiplied by each other, which would give us the number only at the end. It is a series of product of numbers, which would give a number only at the end. And if you divide it by 1, you get 5 factorial. Same. But the thing is, now you may say I'm crazy, but here's the thing. How do we actually prove that 1 factorial divided by 1 equal to 0 factorial when is it already a 1 factorial? My parents always disturb me, man. Sorry for the cut, but seriously, how is this possible? I genuinely had doubts, How is 0 factorial possible when all we do is divide a number, divide by, when all we do, my parents always disturb me. When all we do is divide a number that is 1 factorial, divide by an identity number, by identity rule of multiplication and division. All we do is this, so we get this only. How do we prove that it is 0 factorial? Simply. So technically I don't think this should be possible, because all you do is divide a number by 1. You cannot just get 0 factorial, right? So on this ground and basis, as you see here entirely, okay, I can therefore, where should I write now? Yeah, okay, let's write next page, or maybe can we find something here? Let's put it here only. Therefore 0 factorial cannot exist due to, my parents again disturbed me, man. Due to the fact, no, not fact, due to the reasoning that 1 was used to divide the factorial and attain 0 factorial, i.e. a multiplicative multiplication or division identity आवाज नहीं, oh god, लाइट चली गई, लाइट ही जाती है बस, is used. So yeah, this is the entire thing. I'm sorry for the cuts. My parents always disturb me, and hey, they provide me with pair just to give that thing. They disturbed me. Check everything, okay? Because it's simple. Any number n divided by 1 will be equal to n. Factorial also is applied. So if it's 1 factorial divided by 1, you get 1 only at the end, which is 1 factorial. How do you get 0? I proved it that 0 factorial is not real. Now I'm not saying that 0 factorial uh, does not exist. I mean, I did say it does not exist, lol. But the thing is, no, if I proved some mathematician's theory wrong, some mathematicians prove wrong by that this thing cannot be true, then the thing is that theory would be worthless, and now it wouldn't have any right value for it. To be honest, it's done. Now they have to prove this thing all by themselves, the 0 factorial, right? If in case I'm wrong, please notify me and inform me. I would be pleased to know the way it works. But seriously though, any number divided by 1 would give the same number. So 1 factorial is it at the end. Some mathematician proved 0 factorial is 1 by saying that 1 factorial is this. I mean 1 factorial divided by 1 is equal to 0 factorial. Yeah. So what should I do then? 0 factorial cannot be equal to 1. Yeah. That much. Because at the end, it's my own mistake. I did not prove the 0 factorial is not a non-existent. The only thing I proved that 0 factorial cannot be equal to 1. So now they have to prove that it is equal to 1 or any other number. Yikes. Sorry for the mistake, but hey, if you know, you know. And yeah, my word of the day is the only limit for humanity is infinity, which has no limits. Thank you. Aryan Sardesai. Hey boy, if it's the case then. GG's.